Hi, I'm Bill Murphy. I'm your host here with ASP Enterprises, Quick Supply Company, Bowman Construction Supply, and Cascade Geosynthetics, all part of the Hale Holdings family of companies. And thank you for joining us for the 2026 kickoff of Technical Talks, our monthly webinar series. And if you can't tell, we got a little bit different camera set up. So I'm showing my Peyton Manning 6 head. You only have a 4 head. I've got a 6 head, maybe 7 as I get older. But I'm excited because we have a friend of mine here live and in person. We try to do that when we can. It doesn't always work out, and you'll be tempted to look down there, but of course, occasionally we'll glance up there. But I'll get into the introduction for our guest speaker. But just as a reminder for those of you who haven't been on here for a while or someone that are new, we don't use the chat feature here on Zoom Pro. We use the Q&A. So throughout this webinar, if you come up with some questions, we may look at that during. Sometimes we have to wait till the very end, and we'll get to those at the end if we have time. And we love questions because if he talks as fast as I do and we get done early, it fills time for us. We're going to try to get done right at 1:30 Central, give you 1 hour continuing education credit. You'll get your professional development hour certificate from our awesome marketing team, either at the end of this week or early next week. We're pretty busy with some other conferences. But part of that will be you'll get a survey. For all of you regular attendees, you know all this. So go ahead and get your drink and your lunch and then come right back in 2 minutes. But you'll get a PDH certificate for everyone that attends. It'll come from us, from our company. And part of that will be a survey that comes out right after this webinar that'll ask you to make sure we have the right spelling of your name, your company name. But we ask you to also to ask questions with that survey. So if there's questions that get asked and answered during this webinar, we'll capture those. We'll include those in writing to everybody when we send out your certificate. But we also will capture the questions you send in as part of that survey. And it can either be questions that didn't get asked or answered during the webinar or you need clarification on, but it can also be an opportunity for you confidentially to reach out to us about project requests. So either if you want our guest or one of us to follow up with you, we're happy to do that. It really helps if you have some current or upcoming projects that we can help with. That's good for everybody. There you go. Hale Holdings, I already mentioned this. All 4 companies listed on the right, that's us. I'm happy to represent all of them. I'm our civil engineer. And the Hale Holdings family has other businesses on the explosive side that we don't typically talk about on the erosion and stormwater and fabric side. But we're in the same office here in central Iowa. And I'm really excited to show the next slide, which is our map. But just as a reminder for those of you who aren't that familiar with us, not only are we specifiers with helping up front with the design on projects, we're also problem solvers. So we've got a lot of warehouse and trucks driving staff that can get what you want, where you want, when you want it. We'll touch on that in a little bit as well. So here's the map of the locations for the 4 companies that I've mentioned. We've added Wentzville last year, and we're really excited about the growth we're seeing in some of these parts of the country. But if you see a gray area and you're from one of those gray areas, it doesn't mean we can't be friends. We have friends that do what we do across the country, and our manufacturers work across the country and across the globe. For those of you who are familiar with us, this is repetitive again, but our site solutions, and we at different locations across the United States, we have larger yards or larger warehouses, but we all can provide the same library of solutions, tools for your toolbox. And some of the ones that we don't get to invite to our Technical Talks monthly webinars may still be available for lunch and learns. Just reach out to us. We found out during COVID how blessed we are with this slide here. With our massive inventory, we're a small family-owned company with a very big presence and a very big ability to work on large projects. We eat daily on our small projects, and we have our regular customers that just keep the traffic flowing at all of our sites. I'm watching a truck drive back to a yard now to be loaded up, but we can work on the very large-scale projects as well. We partner really well with our manufacturers, our suppliers. And I really love meeting all of our warehouse and driver staff at all of our different locations because that's where the rubber meets the road, so to speak. So with that, my next slide is going to be to introduce my guest. And I had his picture on the opening slide I meant to make jokes about. He's going to make jokes about it. But I want to welcome my friend Brendon Stieb from Tensar CMC. He'll tell you what CMC stands for. Brendon lives in Nebraska. He's got family in South Dakota, correct? He comes over here and services Iowa for us as well. And he has a lot of coworker friends that cover the rest of the U.S. for them. So throughout his presentation, he might say ASP, and that's okay because I've already given him the grace that you don't have to say ASP, Quick Supply, Bowman, and Cascade every time. He can just say ASP, and you all know what he means. Sometimes you'll hear some of our people say Hale Holdings family of companies. That's harder. So ASP is a short and easy one.
Yeah.
Right?
Yeah. Good morning. Good afternoon to everyone. My name is Brendon Stieb. Today we're going to be going through geogrid at a high level, kind of a geogrid 101, but title here being Optimizing Pavement and Ground Stabilization Performance with Tensar Geogrids. As an introduction here, like I said, Brendon Stieb, I cover South Dakota, Nebraska, and Iowa for Tensar, a division of CMC, which is Commercial Metals Company. Mobile number and email there if you need me. But like Bill was saying, sorry if you saw the LinkedIn posting or the headshot at the beginning of this slide deck. Definitely not as clean cut and young as I once was. I think the
Welcome to the party, pal.
construction industry put a little years and hair on my head. So this is a little family picture just to kind of have you guys get to know me. We've got Taco the cat, Op the dog, my wife Cassandra, and we are expecting a baby girl in May. So very excited about that.
That's why I said you're going to have to learn how to sing in front of an audience.
Yeah,
So
absolutely.
like I told you when we were off camera and off mic, if you don't know the words of the songs, just make them up. Your kid doesn't know either.
Yeah, for sure. All right, jump here into the agenda, guys. We'll go through some safety, quality, environmental, just a quick slide that I wanted to touch on there, and then get into the GeoGrid overview, applications where we use GeoGrid, and then we'll go through some case studies, best practices, and examples. Hopefully that sounds all right for everyone. I know we're all muted, so is that all right for you?
Yeah, I think it sounds great.
All right,
they'll hold you accountable.
I wanted to touch on safety, quality, and environmental, and safety for sure. Kind of a nod to Bill's company here with Quick Supply, ASP, Cascade, and Bowman.
Dude, that's awesome. And you
then
taught me. I forgot to mention our three pillars. Keep going.
And then as well as CMC, who purchased Tensar recently. We always start with safety culture. So this slide here is kind of a working theory that I put together, and when I was putting slides together for this technical talk. So previous to Tensar, I was working for a general contractor in compliance, and compliance was wrapped into the safety, quality, and environmental. And while we were in, it was a heavy civil company that I worked for, and most of the quality and safety topics that were discussed were all based with each other and talked about in kind of the same meetings and conversations. And quality and safety really go hand in hand. So I had a couple stats here that I wanted to touch on, and this is going to kind of try and be a through line through this whole slideshow that we have. But analysis of quality and safety data across more than 500 construction projects found that about 39% of all site injuries occurred during rework activities. We'll talk a little bit about rework as we get into some of these project case studies that we have. And then additionally, workers engaged in rework have a 70% higher probability of injury compared to pre-planned tasks. So like many of you guys who are in industry, whether you're with engineering contractors, I'm sure safety culture is huge on your guys' list as well. And you're always trying to plan for and remove safety potential incidents. So in doing so, we're going to talk about some projects that we've gone through with Tensar in my time, which I didn't mention has been a couple of years now, getting into my second year. But just kind of think about that as we work through this. And if you're familiar with geogrids already, you'll know that a lot of the time when a geogrid is applied, it's because you ran into issues or you had something fail on you. And so that would be considered a rework application or a rework application that you'd be getting into. So
we're okay with those. We're not saying we don't want those.
Exactly. Yeah. Exactly. And then to touch on environmental a little bit too, not sure. I know that the range of this presentation is kind of spanning through the West and the Midwest here. And depending on where you're at, this may hit, it may not, but just know that potentially it is coming. But this is just a proof roll scenario that I have here at the bottom. And this is a super common proof roll scenario, super common issue that we would run into. This isn't out of the ordinary, but we have a 23 kip proof rolling vehicle and half inch of rutting, 1.5% CBR, which is the shear strength or the strength of the soil, and using an unstabilized with zero geogrid or conventional methodology versus a stabilized section with a geogrid. And just to be able to get these metrics, we needed to plug in a size of the site. So I use 10,000 square yards here. And you'll see at the bottom here with environmental cost, able to save up to 45%, depending on which geogrid or which scenario you would pick, which we'll kind of discuss here at a little bit later time. But the potential to save 45% on your actual carbon emission for a relatively small project being 10,000 square yards. So kind of keep these three, I don't know, call them pillars. You already mentioned pillars, but kind of keep these in mind as we go through this presentation. So actually get into it. Sorry, I need to cover my mouth when I clear the throat there. But
I made a note. I'm kidding.
So we'll talk about what is geogrid. So Bill here has mentioned that the Hale Holdings companies are a distributor for many manufacturers, and they do a lot in the geosynthetic world. So a geogrid is a part of the geosynthetics umbrella. Geosynthetics can include and do include geogrids, geotextiles, both woven, being high strength or low strength wovens, non-wovens, geomembranes, geocells, anything to that nature. I'm not sure if I'm missing any.
Oh, you're doing great. Sorry, I was just admiring a Corvette that was rolling by.
Yeah, so each of these are going to have different functions and projects, whether you need stabilization, filtration, separation, total confinement of materials, total separation if you're working in ponds or landfills, things of that nature.
All the above.
So geogrid from a Tensar standpoint, we have three, we call them stocking SKUs. So these are the three that our distribution networks will have in stock for projects on site so we can get quick delivery. And those three are going to be the Interax, which covers NX 850, 750, and 650, which is on the bottom right of the screen, the white one there. And then HX series or H series geogrids, which has also three, HX 165, HX 5.5, and HX 145, which gets confusing, sorry.
Yeah.
And then biaxial geogrids, most notably the BX 1100 and BX 1200. Each of these have different applications and different strengths that we use for design and things of that nature, which we'll talk about here a little bit more. So these are all going to come in rolls, manually installed. They go under a granular material, and we need it to be an angular material so that we can actually get the one of the mechanisms of geogrid, which is interlock, which I'll talk about on the next slide. But that can range from crushed limestone, crushed rock, crushed or recycled concrete, recycled asphalt. We've seen angular sand, larger, low quality material, or ballast and subballast in the rail application. We can use geogrids in soft or stiff subgrades. Most of the time we're using these in soft, but I've got some examples that show competent and passing proof roll subgrades where we've used geogrids as well. So one or more two layers as well. And then just kind of a PSA here at the end. We get this question quite frequently, or we have people come up to us and tell us that they kind of refuse or don't want to use geogrids in their specifications or their designs because they might have to come in at a later date and do something with maintenance and utilities.
Reclamation or whatever.
Yep, full depth reclamations. And it can be an issue. Just as a PSA here, a proof of trenching or augering filtering.
Audio. There you go.
So geogrid in its manufacturing process on kind of like the thing with glass and back down. That's how it holds the structure. But it can, as a force comes through and it's in a actual section layer, be ripped out or augered through. It's all shut up so you can actually hear the popping here of it ripping. One more? Yeah. So just as easy as it comes out, easy to go back in and replace, just cut down a roll, place it back in, fill over the top, and not brand new, but good as new.
Yeah. I like that video. It helps tell the story.
Yeah, I like to hear the popping of it. So how geogrid actually works. So we have two mechanisms or two important mechanisms of how this stuff actually works. So The first being on the left, having an image showing the improved bearing capacity, which is most commonly called the snowshoe effect. And on the right picture, we have the lateral shear flow or aggregate interlock, which I talked about with angular material being placed on top. On the left image, this was a project that we did here in the Midwest, actually a year or two before I actually started with Tensar, but the shear strength of that soil was 0.3 CBR, which is about as low as it can possibly get before you would be considered actual water and not being able to build on top of. There's a really high water table, and the soils were pretty silty in nature. And so the minute that they opened it up, that water filtered up and became just kind of a slough. As people were walking out into this area, and there's kind of a cool picture on the next slide or two slides from now, but the people that were stepping off of the geogrid actually were sinking about to their knee. But as you see them walking and pushing out the geogrid behind it, kind of acting as a snowshoe. And so the different classes of geogrids, having the Interax, the H series, and the biaxial, all improve bearing capacity at a little bit different variations. So if you think about a biaxial, you have an X and a Y, and so you're only distributing load in kind of a vertical and a horizontal X and a Y. We call it radial distribution with the multi-axial geogrids. So the HX and the NX are going to spread load concentrically out throughout the width and length of a geogrid.
Well said, concentrically. That just flew right off your lips, your tongue there. Good job.
So for the second mechanism, we have aggregate interlock, and the right image shows this. And this is a Tensar demonstration that was done, here in the past, and it's on YouTube if you want to go see it. It's pretty cool, and Brian G does a good job of actually explaining it. But I'll try and do my best here. As this example, we have a box, and it's a box of rocks. We're located in Atlanta, Georgia. So this is a DOT Georgia ag base. And on the left-hand side of the image, you have the box that they compact in layers and use no confinement or no geogrid to confine materials. Picture on the right, box of rocks where they use a couple layers of geogrid, confine it, pack it in the same intervals. And as you add load and pull the confinement on the sides, you have movement of material with no stabilization. And then when you have stabilization, you get particle confinement. And as you get particle confinement, that works its way up vertically through the ag base itself. We call that a mechanically stabilized layer, which is what gives the strength to the section and why a geogrid would work in scenarios like this.
I love that demonstration. It's been around for a long time, and G does get excited about it. I mean, it's easy to get nerd out on it.
Yeah. So again, I mentioned that we need to use angular material, and this is why. If you think of a river rock or a river stone, something rounded, you're only going to enact one of the mechanisms of how geogrid works, which is bearing capacity. And really, to get a properly engineered solution done, you want to use both of these. And so the angularity of the rock itself striking through the apertures of the geogrid and not being able to move is what helps us build structurally vertical. So now that you know how geogrid works, here's a properly engineered solution video that I'll just show you here quick. See if that rolls.
No audio.
This one does not have audio.
Go ahead.
Well, you can narrate it.
It looks awesome. I want to drive that truck. And you're going to go right off the geogrid right there.
Yeah.
You can see where the end of the geogrid is.
So yeah, total failure. I'm biased. I really like this video. I think it's cool. It's one of the first ones I watched when I started with Tensar and was like, wow, okay. That's what geogrid can do. So this one has, let me get to the end of it. So jumping into geogrid's primary applications, anyone who's familiar with geogrids is going to know that it works really well in stabilizing soft soils. And this is where we get generally most of our calls is, if it's rainy or you open up a highway project here top right and you have a high water table and silty soils and you bury an excavator, this is a perfect opportunity for you to call your Tensar representatives. I guess a little less notable or less significant, but becoming more prominent are building firm working surfaces, working platforms, whichever nomenclature that you would want to hear, but that's when we're using any sort of heavy equipment and we're out trying to build structures, or we have a heavy haul road where we're pulling material in and out from laydown areas back to the project site, things of that nature. We can enhance. I saw you smile.
I did. You're not covering your mouth. If we had an audience sitting there, I'd
I
be
know,
smacking you with the ruler.
Bummer. So, third here, we have enhanced pavement service life. We'll go through an example of that, but being able to increase the amount of traffic that a road can see, whether it's unstabilized or, excuse me, unpaved or paved. In the rail industry, we can stabilize ballast and subballast. This is
Huge.
huge in any sort of renewable industry or petrochem, anything like that. Usually we have some sort of rail station coming in and out of there. So a big opportunity for us. We have the, kind of speeding up construction timeline. I guess this is less of an application, more of a benefit of using GeoGrid, and have a really cool example at the end that shows some pretty significant speeding up on construction
The
timeline.
whole audience will feel that one because
Yeah.
the more projects we get, it's not like they're giving us unlimited budgets and free time to do it. There's a lot of pressure on time.
Right. Hopefully you didn't come today to learn about walls and slopes. Tensar does have geogrids that we use in reinforced slopes and walls. Today we're going to be talking mostly in or all in horizontal applications and not in the walls and slopes.
But you have people on your team that are very good at
Yep.
walls and
And
slopes.
absolutely reach out to me and I can put you in the right camp for doing walls and slopes design. So we will jump into each of these applications called engineered solutions for us, right? So to start with, we'll just start with the one that's most notable, which is stabilizing soft soils. So this is a project in the Midwest that was post-bid. They were already starting their work and just for some reason had a rainy season during the summer months and trying to get this project completed before the harvest. So essentially, they were trying to replicate the building that you see on the right because they needed more volume for the grain that was coming in. They were unable to pull in any of the equipment to erect the walls for this structure, and therefore they needed something quick that they could get back on schedule with. The soil here, if you're familiar with loess soils, they're pretty common here in the Midwest, but it's a soil that as it gets any sort of moisture to it, loses all structure and can be really greasy, oily, and squishy. So definitely needed to get something done here. Wow. So we were able to scrape off kind of that top layer and get this project closer to a grade that was going to be constructed. This is a Tensar offering, is a DCP test, dynamic cone penetrometer. But I do just want to make a note, right? This is something that we don't want to take our steel work away from geotechnical engineers.
No.
We always wish and hope that the geotechnical engineering person that's on contract go out and actually do the soil testing. But in a pinch, you can absolutely reach out to your Tensar representatives. We all have DCP tests, and we can go out and do these. So a little explanation on how this works. You have a rod with a cone at the bottom of it and a 17-pound hammer that you raise and drop. And what happens is, depending on how soft the soil is, you'll get either deeper penetration or lower penetration. And we take readings on those, and you can model the top 3 feet of soil with this tool. I have 2 tests here that we ended up taking, and it kind of shows the difference even 20, 15, 30 feet can have on a project site. And when we give our recommendations, typically we want to use kind of a worst case scenario, but there's a little bit of an art to it where we can kind of blend both of these. So for this example, right, the depth is on the left side of the chart, and then CBR is on the top of the chart. Like I said, CBR, California bearing ratio, is just the shear strength of the soil. And as you get further right on the chart, the more competent it is. So under a 1, which the top one is really soft. And that's what you saw in that first image where you get a telehandler that's just rutting the heck out of the site. The one on the bottom, that's 1 or above, this one's actually around a 2, that's a lot less soft. So when you call an employee, Tensar employer or a contractor calls engineering and they say, hey, we have soft soils. How do we deal with it? This is always going to spark or be our first question. Well, how soft is soft? Because here I'm able to stand in it. I'm probably sinking, bigger guy, sinking about an inch or two in my boots versus, the one I showed on the last screen, which is as soft can get. So this is why it's important that we go out and actually do a model of the soil at that time. So for this project, we ended up using kind of the worst case scenario. They didn't want any point of contention, point of failure, because this thing needed to go. The other input that we needed on this one was what the expected traffic was going to be. And for this one, it was all 18-wheeler tractor trailers, which was all the grain truck and trailer that were going to be coming in and out of the project site. We designed this one to 100,000 visits or 10,000 visits over 10 years with a certain rutting parameter that was allowable for the engineer with little to no maintenance, which was in this instance, I believe, 2 inches. So I drew a box around the potential savings. So you'll see 4 different section thicknesses, and this is where a Tensar engineer or what we do is train engineering community to use our Tensar Plus software. Mm-hmm. This is the kind of the printout cutout that we're going to be able to get on a stabilizing soft soils application. So at that 1% CBR that we had with that amount of truck traffic to enact the same benefit of actual traffic, you would need either a 31-inch unstabilized section or with what Tensar calls a good, better, best solution, which, disclaimer, does change region to region, or depending on what our distributors have in stock, these good, better, best situations do change. But for this certain one, what we had in stock in the area, we went with the 3 that are shown on the screen. I put a box around the total savings, and these are all based off of or compared to the unstabilized, but you can still see within the 3 that are actually stabilized with geogrid that there's even more savings. So from the NX 650 to the 850, you're saving roughly 10% with 5% in the middle, all based off of the material used, the excavation, the man hours that it takes to complete this project. You'll see another cutout on the right side that shows, at the most for construction costs. These are all estimates, by the way, too, and based off of, well, as close as we can get with material pricing or things of that nature. But saving 52%, saving 58% on construction time or 13 days, which was huge for this one. Obviously, like I mentioned, they needed to get the structure erected for the harvest season, and then environmental cost again. Saving 56% on carbon emissions over the totality of only this portion of the project, which is pretty insignificant when you think about what all work actually had to go into this. So based on material stock that we had for this project, we actually did 2 different sections from the previous slide. We did all the outside in NX 850, which was the 11 inches. And then on the inside, where there was only going to be static loading from grain, we did a different section with the NX 750, and I believe it was 13 inches. And that was based solely on not being able to get equipment in and out of there, continuing to have soft soils in there, rainy situation. But just kind of to highlight that not every project has to be a one size fits all. Yeah. We can work around depending on traffic and things of that nature, that we can kind of hone in the value and which SKUs that we need to put in on a project. So talk another stabilization project, but this one is different in the fact that the subgrade was different, and this was more to do with compaction. So this is a design.
It was rude of me to do that to you.
I know, right before the yeah. For this one, we were sent this cutout here from the engineer, and this was going to be a low volume road, but it had highway access, and there was going to be some heavy equipment or heavy traffic due to multiple industrial sites in town. So we have a 8-inch PCC pavement, 6 inches of subbase, and 12 inches of subgrade prep planned for this road. And based on the state's manual, the estimated traffic was 3 million easels, which is an equivalent single axle load, and it's just a value that can be given for how much traffic is expected for this roadway. You can see here the boring logs that were sent to us, and the two that were mainly in question are 7 and 8. And as the project came and they scraped away the top layer in order to get to what grade that they wanted to actually design and build this roadway with, everything kind of went away, and it was all a silty fine sand. What we had at the time as well, again, was heavy rainfall in the area.
Oof.
And when this sand got wet, it lost all of its competency. And when we actually went out to site to do the analysis of the subgrade on this one, noticed that it was in a super cool environment, heavily wooded, heavily shaded, and there was just no drying the sand out. They tried multiple rounds of subgrade prep, kind of to no avail. They couldn't get the compaction that they were looking for. So the design that we were working with, based on recommendation through engineering and through the contractor, was wanted to kind of try and stick around with the grade that they had already dug this thing out to, which was 12 inches. So we ended up going with, again, an NX850 install and kept the 12 inches of material for them. The main concern for this one was the amount of traffic that it was going to hold unpaved. Due to the city or the town that it was built in, access from the base of the hill was not allowed because they didn't want to damage that roadway. It wasn't designed to handle ready mix trucks. And so if you see the top left image, this is going up a hill, left to right. And so the ready mix trucks were planned to come and back down the slope all the way down and then build back up. And so we did go out on site for the install of the rock, and then again with the concrete, and the contractor was head over heels at how it actually set up. So
that's awesome. Hey, you're just past halfway.
Okay.
Perfect timing on the slides. Get a drink, and then I'm going to check a question that came up over here. If I can do it without ruining everything for us. If I ruin everything, we'll just start all over again. I'm just kidding. And I'm not sure if we're going to get to this. Yeah, so this is a good friend of mine, Matty Gibbler. Do we have a savings comparison to lime stabilization versus more aggregate? Is that part of the initial tool, or is that more in-depth?
That's going to be more in depth, and it's going to change project to project, depending on the actual depth of tilling in that we're doing with a lime or a chemical stabilization. I've also seen in a chemical stabilization bid tab, things can kind of go from you have your lime, fly ash, or cement contents, you have water. So it does kind of get a little bit gray on what material is actually being used, and what pricing is being used for a cement or lime stabilization.
Thank you.
So yeah, we would need to be more involved, and we don't have a tool currently that we can do it. But
so Maddie's a good friend from Burns and Mac in Kansas City, so that'll be a good one. I can follow up with her with you, but we can bring Libby in if we want to help answer that, or Phelps or Young or whoever.
Yeah.
So
absolutely.
Thank you, Maddie, for that question. Good question. Everybody benefits from those questions. There you go, buddy.
All right, we're back on.
Thank you.
All right. Switching gears a little bit. So we talked about building firm working surfaces, and I have large material volume on this one because it was a bigger project. It's a 40,000 square yard job. Most of the time when we're working with firm working surfaces, we're actually building our project on what we call suitable soil. So the subgrade itself is typically passing proof roll before we add grid and granular material on top of it. This was in the design phase of the project, so we could kind of decide with the engineers which way we wanted to actually take this one, based on what was designed in the specification. So this is a hospital expansion, and there were two, I guess, key factors to this project. You can see all the yellow equipment that was on site. These are all going to be the crawler cranes and drill rigs, and where they were planned to be during the extent of the project. And then kind of that blue shaded rebar operations area was all going to be lay down and storage for heavy equipment and equipment coming in and articulating and pulling and putting material in. So the design that was used for this was based on the equipment table on the right with the peak allowable ground pressures. So we had the drill rig and the crawler crane, and the engineer had this as a dual layer. So I mentioned you can use multiple layers of geogrids. You'd want to put, if you were doing this grid on subgrade, native subgrade, whether it's the clay or whatever, put rock on, and then halfway through your section, you'd put another one, put more material on top of that. For this instance, with calling out Tensar BX1100 or equivalent, we have different products that can kind of reduce or do reduce the amount of material based on performance of the grid in this situation. So what we were able to do, so step one was to piece together a new design which the engineer would consider equivalent or better for this scenario. So the project specification required that, like I said, the subgrade pass proof roll before the rock actually be placed. So there wasn't really a worry about having soft soils for this unless weather became a factor. The input that was used for the native subgrade for this one, and this is based off of the calculation method on this one. So 1,500 pounds per square foot, and that's the undrained shear strength that we used. So these three sections are not all considered equivalent, but the two on the left, or the one on the left and one on the middle, would be structurally equivalent based on years of design with BX1100 in these scenarios. So 12 inches, 12 inches, 2 layers of BX1100, or just having a thicker section with BX1100 at 28. The design methodology that we use, which is a T-value method, which I'm not going to go into detail of because it's very complex and probably would take an hour on its own, but we definitely have people internal that can take you through it and walk you through it. If you want to reach out, we can get a lunch and learn set up on it. But the section that we used was 12 inches with NX850. Any sort of heavy equipment, we wouldn't want to go below 12 inches, especially in this scenario with how heavy the crawler crane and the drill rigs and all that were going to be. So this section actually performs much better than the two sections on the left with the 12 inches and NX850. This is kind of a busy slide. Just
that's small.
Yeah, don't think the notes are not what I was trying to draw a conclusion on, but the cutout that I did kind of takes it all into account. But
good.
Step two, prove solution works, and this was all based on a factor of safety, bearing capacity factor of safety of 1.5, which you'll see in the table. Unstabilized was never really gonna, as the project was being designed, it already had stabilization and geogrids in it. The way that our software puts these out, it automatically kind of classifies it with an unstabilized. But the point of this was to show that through this addition of the design that we did with the T-value increase was to show that, hey, we can pass the bearing capacity factor of safety of 1.5 with the 12 inches of NX850 for this certain piece of equipment. So I have noted that I need to mention what the T-value deal is without going into too much depth, but it's derived from the relationship between mechanically stabilized layers and the increase in T-value. So it's a design methodology that's in DFI, which that's about as far as I'm going to go. So
okay. That's fair enough, but I like that you offered a lunch and learn if they want to get more in depth, or reach out to us. I mean, that can be handled with an email or phone call as well. So yeah, we'd love to follow up with you.
Again, construction cost estimate. So I had, unstabilized wasn't going to be a thing, but I highlighted what key point I wanted to make on this one, right? So the aggregate base is substantially more when we use 24 inches versus 12. The geogrid price on NX850 is much more than the BX1100, but as you can see in the total cost, able to save around 221,000 square yards over that 40,000 square yard project, and that goes back to grading contractors, the general contractors, and the owners, and however they decide to split that out, since this was in a actually pre-bid phase. So
yeah, that's a big number.
Yeah. And install day. So
beautiful.
Project is still going. I need to get some actual pictures of, I'm sure there's a lot of activity on it now. This was late summer when we went out and took these pictures. So talk about another pre-bid design, firm working surface project. Again, working surface here. So we had the design that was originally the 12 inches and BX1100, and the subgrade itself was competent. Again, 3% CBR is considered passing proof roll, shear strength for the soil. There was a lot less that went into this one. This is an engineer that uses and specifies geogrid all the time as a factor of safety bonus. So we were just able to kind of show, hey, you can use a BX 1100 in this case, or are you open to investigating or looking into other solutions that might save time and money? So what we ended up going with on this one, based on the equipment that was going to be on site and articulating nature of some of the equipment, we could have passed and done well in this instance with 6 inches, but we had a 9-inch for added factor of safety. So this ended up being a much better solution for the engineer and the contractor and the owner on this one, and still was able to save 12%, which isn't quite as significant, but still a drop in the bucket for sure on really not the maybe 1% or 2% of the actual project was the geogrid install. So another thing that was nice about this one was we went from the specified crushed limestone to a crushed concrete, which was an additional adder for the money that was saved. Like I had mentioned, you can use crushed concrete in lieu of a crushed rock. I kind of want to put out a disclaimer that this is not the case nationwide. We're lucky kind of in the Midwest with the quality of the concrete that has been put in, but I know I've talked with some colleagues around the areas, kind of more in the South, but they really stay away from any crushed concrete. But what I will note is that the new kind of multi-axial nature of the geogrid does confine non-quality materials a lot better than the biaxial geogrids have and do. So
well said.
Definitely get in contact with a representative if you want to look at using less quality material.
There's never an obligation just to involve us. I mean, us or you. I mean, it's great to have these conversations and give a printout and give some options. But I think it helps everybody on here, whether they're the owner, the engineer, the contractor, anybody involved, consider their options, right? We all do that at home anyway. We do it with our own money. And then there's no obligation. We're not going to tell you which one you have to pick. We can lean our favorites. It's like, man, I'm an engineer, so I'm pretty conservative. I like the better geogrid. I like a little more rock. I mean, that way, less likely to get a call back or less likely to have somebody disappointed 20 years later. So,
yeah, absolutely.
Thanks for letting me interrupt it so you can take a drink.
Yeah, you bet.
Let me smell that glass. What's in there?
Some more install picks. So it's kind of a nice little fall shot, and then here another one of the project and being installed. So starting to spread out rock, and the next one even more, and going back in and compacting. So this one is sort of by my house. I drive by it all the time, and I always smile.
I'm a sucker for time lapse. I mean, even in our industry or beyond our industry, I just love to see a story come together. And I have the ADD or ADHD. Remember we talked earlier, and I don't have time to watch the whole thing, so I like the speeded up version.
Yeah. All right. We'll talk about pavement optimization and design examples. So most of the projects that we've talked about currently have been cost savings. This is going to show more of a sustainability or longevity mindset. And kind of what he was talking about, Bill was talking about just a minute ago of, we don't always want to take out as much material as possible. As engineers, we're always looking for kind of that factor of safety. And I think this kind of proves that example of let's try and create and design a situation that, yes, it's going to save money versus kind of the original design or original plan, but let's add value, which is kind of the, it's half of the wordage of value engineering is we're adding value. But we're also able to save some money. So I'll walk through this example here. So if you were to design what we considered a standard section of 2 inches or 8 inches total of asphalt and 6 inches, and based on AASHTO 93, which is what all of our geogrid is kind of calibrated to, this design methodology would get you around 730,000 easels for your traffic loading. So you have 3 geogrid examples that kind of show what can be done through design. So you have your lowest life cycle cost. I would say this is the one that, if the taxpayers maybe had their way, this would be the way that it would go, because you're 4xing the life of that pavement. You take 730, you turn it to 3 million, and then you don't have people complaining about potholes and this, that, or the other, constant construction. But it's also significantly more expensive because you're only including the price of geogrid into your square yard price. Installed cost of that being around $6. So you're at $56 instead of 51. So yes, more expensive, but you get a whole heck of a lot more life out of it. You have your lowest initial cost, and this kind of tends to be the one that people gravitate towards because it's the most cost savings, but it doesn't give you the best benefit. So essentially, you're getting the same life out of your pavement as you were the original section, but you're saving $5 per square yard, which adds up obviously over the extent of the project. So able to shave out material. So in this case, 2 inches of asphalt and call it a half inch of actual aggregate. 3/4 of an inch isn't really that doable, but so just showing, right? You could theoretically take this section down to get to your life. But I think in my opinion, I guess the best solution possible project is kind of already budgeted for the $50.99 per square yard. That might be the original design as well. So just take out enough material to give you maybe $1 off per square yard in savings, but getting 77% more life out of the pavement section itself. In doing so, you don't scrub out as much material and you add that geogrid in there as well.
Leaving that up there for a second, I feel like when we talk about us as consumers, whether you're buying a washing machine or you're building an addition on your house or re-roofing your house, you kind of look at the good, better, best options. People ask for that all the time. I think it's because they see it in other industries. They might go to a big box store, and some of these stores might literally label them in some of their marketing as good, better, best. We try not to do that because we don't want to offend any of our suppliers. But as we just have the conversation with you about your project, we get that opportunity to give you a few different scenarios. And every person's different. You get the people that are like, I'm only working for 4 more years and I don't want to get yelled at by whoever is on an election cycle. I want the lowest cost. Then you get the others that are like, I'm sick of being the maintenance guy or having callbacks and we're just tired of junk and we want the very best because we don't ever want to come back out of here. And I have 20 years left in my career. But a lot of people fall in that middle of the road kind of a compromise.
Yeah.
We're not saving the most amount of money, but we're not over designing it. So we're kind of in the middle. But that's up to every personal preference for all the stakeholders. But I think it's great that you can kind of create value on those and show, like I love you said, add value, but let somebody else make the decision. So let the team make the decision.
Yeah.
And we might lean over and whisper our favorite out of those, but that doesn't matter. Whoever's writing the check and paying for this and going to own it long term, they need to evaluate those. I love that. So well done.
All right. I do have an example of what would consider pavement optimization as well. So this was a project that was specified by the county engineer. And to be honest with you, I wasn't heavily involved in this. The project was kind of designed before I actually came on, but it has been installed so far. So this was a full depth reclamation project. It was a concrete road before. I believe it was slab on grade, which could be the reason that they're coming back and redoing it. But they did end up going with an NX650 geogrid, which you'll see in the left photo. And then that crusher out in front of it is just recycling the concrete and putting it back on top. The engineer had designed this with budget and longevity in mind. So what I'll show you here, I guess, on the next slide is they actually went in and created the road and left it unpaved from probably around March timeframe to September timeframe. And again, Midwest here, this is a super agricultural rich area. So they're going to have a ton of ag equipment that's going to be coming through and potentially rutting up the road, which effectively, if you didn't have protection for the subgrade, would rut the subgrade. And then when you go to pave on top of that, you've already failed your most important part of this project, which is the subgrade. So as the subgrade fails, you kind of at that point are stuck and have to go in and do another full depth at some point. They did go back in the second, I'd call it, they had one fiscal year. Most counties probably fall on like the June, July fiscal year. So you had half the project installed in one fiscal year, half of it installed in a second, which kind of talks to my point on budget. But then the longevity point of this is, I'm not sure if they came back in and scraped material off or if they came in and paved on top of that. But whether they did or didn't, they added more traffic capacity, more traffic value for this by implementing the grid, leaving it in place, and then coming in and paving on top of this.
A creative solution.
Yeah. All right, here we have the last important slide. I would say we have a thank you wrap up slide, but so touching on the timeline, speeding up construction timeline. So this one kind of does actually have all the major benefits of utilizing geogrids. So it was a pretty large project in the region, and it has been installed, and that's pretty much all I'm allowed to take it as far as I can take this one. The soils were super poor, so we have a 0.7, and they needed a solution because they had super heavy haul equipment coming in and out that was taking materials to and from certain points on this project. So they called up and needed something quick. They needed to kind of get back on schedule here. And we went out, did some DCP testing. We modeled the subgrid for them and came up with a solution that was either 33 3/4 inches of material unstabilized, or come in with a geogrid and knock this thing down to 13.5. So you'll see on the bottom the construction cost, construction timeline, and environmental cost. They really weren't actually concerned with how much money they were going to need to do the installation. The key factor for the contractor and the owner on this one was the construction time. And I think there were some potential benefits or incentives and bonuses by completing kind of the path of the important path of schedule. I can't remember what they call it in the construction industry, but anyway, being able to save 3 months of construction time by just implementing a geogrid, you have plenty of money actually saved. So the price of the geogrid really doesn't matter in this instance, but being able to come in, wrap this project up 3 months ahead of schedule, or ahead of the proposed schedule if they went unstabilized here, plus 455 tons of carbon emissions were saved. This was a pretty big project, and just kind of giving back. I know there's a lot of environmental incentives coming out as well. So
yeah, that's been interesting to watch that navigated, because some old guys are like, that's how we've always done it. We don't care about that. That'll never happen. But then now some government packages are literally listing that in there as part of the scope of the project. And I think that's the only way that it'll ever change, is if it has to be built in up front, as that's an expectation of the project.
Yeah.
It's a little hard to convince. Like, I have friends who are old school. Some of them are maintenance guys for counties, and I can't say where, and they don't want to do anything new or different. So that'll never take off. And then you watch as it evolves, and that becomes a bigger thing. You do care about maintenance long term, so we have to build it in up front.
So I did start my portion of this presentation with kind of the safety and quality aspect, and hopefully you didn't forget it. But as we kind of draw this presentation to a close, installation of geogrid is really a low risk construction activity. But kind of the butterfly effect of installation, right? If you were able to save 3 months on a certain task, that's 3 months of potential safety incidents that don't occur, right? So yeah, we're not erecting anything structurally, but when I was working for the general contractor that I mentioned, it was winter. Someone came out, slipped, fell on the ice, broke their collarbone. Freak things can happen. So just kind of another, maybe think outside the box on making sure that we have a plan in place beforehand, and kind of not reacting to any situations that we find out on construction sites would be kind of my hopefully draw through. Kind of wrap up that thought. But you have anything else?
I do. Okay. My mind races all the time. Like I saw that Corvette at the beginning, and I heard a loud engine. At first I couldn't tell what kind of vehicle it was. But as you said that, it sounds like something an old person would say. What do they say? An ounce of prevention is worth more than a pound of cure. So if you plan ahead, and the prevention part would be how to plan ahead to be more efficient with our resources, but also more efficient with our time. You and I talked about this last year during some lunch and learns. Yeah, the time savings connects right back to safety. You have fewer chances of somebody getting injured on a job site, but you also have less traffic, so less rock haul loads, for example. I use that one all the time. A lot of our solutions, we're not anti-rock. This building was put here because of being a distributor of explosives in the mining industry. So Quick Supply Company, our parent company owned by Hale Holdings Company, Quick Supply, is in the blasting primarily for rock. So we are in rock quarries all over the country now. So we're not anti-rock. We're how to use that rock better or smarter. So my friends at a rock quarry here in Iowa, where we're sitting right now, said they want to use geogrid more on some of their projects, not because they don't want to use rock. They love rock, but they'd rather sell that rock to somebody else who uses it somewhere else. And my pitch to county engineers and DOTs is, we're not anti-rock. How about you use less rock to solve this problem here? Because I'm looking at the map on your wall, and you have it color coded with A, B, C priorities of what needs fixed and what you have budget for and time for.
Right.
How about use it somewhere else? So now you can now solve 3 projects instead of just one. So that planning can help you versus responding with a cure. Now we get our weekly calls and deliveries are the cures. We get soft soils, we have an emergency, we've got to get this project closed, whatever it is.
Yeah.
We still will do those.
Yeah, absolutely.
You and I
talk plan everything.
The big projects, those get everybody excited. They get your employer, my employer excited when we have those great big projects, highways and railroads, whatever the case may be. We want both. We need both. We need them all.
Yeah.
But I think you did an awesome job. I didn't even mention our 3 pillars starting out, our 3 values. We rolled it out last year. It's safety and family and customer, not in that order. It's in no particular order, safety, family, and customer. I'm supposed to include that with all my presentations. But since I'm just introducing you today, I shortened it and I cut that out. So I'm glad you
handled it.
You gave me a nod that I didn't deserve at the beginning of your presentation. But no, this is your contact information. Yep. And there are people in your company that I've known a very long time who get super jazzed up about nerding out on the design methodology, or they love a DCP, or they love to come up with the what if scenarios of the different solutions and examples. So you mentioned Lunch and Learn. I've watched you in action on those and some of your counterparts. I've even been down to your facility in Georgia and got to see how this stuff is made. But I think you're doing a great job of telling the story. We only have a few minutes left. I'm going to click on a couple slides. When I land on this, friends, sorry for all of you in Kansas City and St. Louis that are looking for our annual clean and green. We're not doing it there this year. We had some staffing changes and we have some blessings. I don't want to spoil anybody else's story. He's got a baby on the way. We've got people in our work family that have welcomed some new babies, and we have more coming. That's pretty exciting. So for various reasons and some conflicts with some other schedules, we have 4 clean and greens, not in Missouri this year. But our Bowman Construction Supply is going to go to a new market for clean and green down on the south side there. Pueblo, Colorado is our first one, Tuesday, February 10th. 2 days later, I'll be in Salt Lake City, Utah again with our Cascade Geosynthetics family. And then the following week, we're coming back here to the Midwest. Omaha, always a wonderful turnout at Tiburon in Omaha on Tuesday the 17th. Since it's so close to right here in Des Moines, Iowa, we're going to be in Ankeny at Toast again on Wednesday the 18th. If you click on that QR code, that'll give you access to all 4 of those. If you want to come to all 4, you'll see me at all of them. If you want to come to just one of them, do that as well. And then I'm going to leave it on our contact page while I go look at the Q&A, because I saw a couple more questions pop up. And we have a minute and a half left. Kevin's asking, can you provide the procedure for design of pavements using GeoGrid and how to account for the GeoGrid in the pavement design? Yes, Tensar Plus. How can you find that online if you tell him real quick?
Yeah, tensarplus.com. And every design methodology that goes into each of the modules that are in there, there's a resources tab at the bottom that will explain explain all of the procedures for design of pavements and the calibration of the material that we actually use in those pavements, which I didn't have time to discuss today.
No, and we don't have time. We got a couple other questions. We're going to capture those in writing, and we will talk about the difference between HX165 and the NX series. And thank you, Michael, for the critical
path. Thank you.
Critical path. Thank you for those questions. We will get into those in writing, because Brendon and I are going to capture those questions, and we're going to respond to all of those in writing. So everybody attending here is going to get a PDH certificate, and you're also going to get the written Q&A for all of that. So with that, I want to say congratulations on your good news coming your way. And I was going to take you to dinner tonight, but you got to go to a class tonight, which is very important. So congratulations. Thanks for being with us. And it's water in his glass. I helped give it to him. That was just a joke. Thanks, friends, for joining us. We are out of time here, but we will answer those questions. And you'll get a chance when you get that survey to send in another question and or projects that you want help with. And Brendon has counterparts across the country He has his states of responsibility, and no matter where you're at, if your project is in one of those, he will still be able to help you. And to the friends of ours who joined us outside of that area and outside of our area, still stay in touch. We can put you in touch with the right people that can help you. And I have friends in our industry who are seen as competitors, but they're also distributors, but they do what we do. So there's a whole lot of people that can help you with your solutions. I would appreciate it if we could hear directly back from some of you on this. If you have a project that even if we don't end up servicing it, we can still help you solve problems. Your success is our success, and I'm glad you're with us. So happy New Year. Happy 2026.
All right.
All right. Thank
Take
you,
care,
guys.